Okay, hi Year 12. We're up to question 17 now, and it looked like this below. It gave you a diagram, and it was of a function y is equal to 4x over x squared plus 1. And what it wanted you to do was to find the region enclosed by the graph, the x-axis, and the line x equals 2. So it's basically finding the area of the shaded region, and you needed to find that in your exact value. So I didn't want a decimal for that. The question is worth 3 marks. Overall, this question was not done very well. What a lot of people tried to do was try to look at it as one curve, being that top curve there, and another curve, being the line x equals 2. And there aren't two curves in there. It's basically finding the area under the curve, 4x over x squared plus 1, between 2 and between 0. So x is 2 and x equals 0. Okay, so what you're trying to find is what I've got down under here, the integral of what I've got there as the curve between 2 and 0. And what you should have looked at is, you should have noted that there isn't a rule for integrating a function on the top and the bottom. You should be thinking that that looks possibly like a logarithm, and that's what it is. And when we're integrating something that is in the form of the derivative on the function, that is when we're going to have a log. Okay, so if we think of our bottom line there as being our function, our x squared plus 1. What is the derivative of x squared plus 1? That is 2x. That is different to what we have here, is we have 4x. So we actually have twice the amount of the derivative on the function. And that is where a lot of people also went wrong. What they did was pop a half out the front because they weren't really sure what they were doing. So get yours in the form derivative on the function, then fix it up by multiplying or dividing so then it looks like what you do have, and now we know what we've got, and that's going to be between our limits of 2 and 0. We've got two lots of, and I'll pop my square brackets in there and we'll integrate it. It's in the form derivative on the function, so that means it's the log of our function. And that's not your answer. You need to sub in your values now, so you're going to have log of 2 squared, which is 4, plus 1, which is 5, minus log of 0 squared, which is 0, plus 1, which is 1. A lot of people got to that point but didn't know what to do. You can simplify this further. What's log of 1? Log of 1. That's telling me e to the something gives me 1. E to the 0 gives me 1. So that's a 0. So I end up with 2 log of 5, take away nothing, and that's my answer. It's in exact form, and I don't want a decimal. So to get your full marks, you needed to do all of those things and to get that answer right there. Okay, so I was looking at allocating 1 mark to get your integral into this format, 1 mark for integrating, getting the primitive correct, and 1 mark for substituting in and getting me an answer that was correct in exact value. And that's where your 3 marks came from. Okay, this one was done fairly well. It's worth 2 marks, and you need to note that the integral of sec squared x is equal to tan of x. So you need to have a tan of x in there. So that would be your first step. Integrating sec squared x gives me tan x. We're popping our integrals in. It was a 2 mark question. You would have got 1 mark to do that. Your next step was subbing in your limits. Tan of pi over 3 minus tan of 0. You're going to go and use your special triangles to work that one out. Okay, tan of 0, you could pop that in your calculator, is 0. Tan of pi over 3, I don't know if people didn't know what pi over 3 was. So pi is 180 degrees, 180 divided by 3 is 60. So you're basically just working out what tan of 60 degrees is on your special triangles, which are on your HSC formula sheet. So you've got root 3 minus 0, which is just root 3. I did not want, and that was the right answer. That gave you your 2nd mark. It needs to be left as an exact value answer. Okay, we don't want a decimal for that one. Okay, rightio. This one, I think people were looking at being a little bit harder than what this question was, number 19. So the table below represents the present value of an annuity. We've got the number of periods at the side. We've got the interest rate per period as a decimal. So you need to use the table to make it a lot easier. What would be the present value of a $2,000 per month annuity at 1.2% per annum for 25 years compounding monthly? So there's a lot going on there. Okay, it's monthly. We've got 1.25% per annum. Okay, step one, you needed to get that 1.25% and change that to monthly. So 1.25% divided by 12. I'll just quickly do that up here. Okay, there's our value. Let's divide that by 100. Oops. What have we got? 0.001. That's the number we want to work with. And we're looking at 25 years. 25 years times months is 300 months. So that's 300 months and I've got 0.01%. On my table, I'm looking for this value here. If you just did that, that would have given you one of those 2 months, one of those 2 marks. So what the $2,000 per month annuity means is you're popping $2,000 in each month. So what would be the present value? The present value is going to be $2,000 times the rate that you've got up the top. And that gave us $518,141.40. That's the present value, or the amount that you would need to have that would equal you putting that money in the bank over those 25 years. Okay, so we're still using the table for part B, and now it says Thomas borrowed $600,000 to purchase a home with interest charged at 1.5% per annum, and it's still compounding monthly. So we need to change, like we did above, our rate of 1.5%. We're going to divide it by 100. Okay, and then we're going to also divide it by 12 to get our monthly rate. So the rate from the table that we want is 0.00125. So he agrees to repay the loan by making equal monthly payments over a 30-year period. 30 years times by 12, which is going to give us 360 months. So again, you go up to the table, you find your 360 months and you 0.00125, and our new value that we want is the 289.7541. So this question is basically the reverse of the last time. We basically now have the present value and we want to find, like our 2,000 amount that we're popping in each month, we want to find what that is for this question here. So I've basically got 600,000. Oops, sorry, my pen's mucking up there. Is equal to something times my rate. And that's something I want to find. So if I just divide my 600,000, divide by that amount that's on the table, I'm going to end up what my monthly repayment is. And that is equal to $2,070.72. That's the quick way of doing it. People actually did it the long way using a geometric progression, and you would have got the same answer if you did that. But if there is a table, it's going to be a lot easier to do that table. Okay, next one. Okay, trapezoidal rule, 3 marks. Now, this one I was a little bit disappointed in because people did not seem to copy the rule down or have a good understanding of what the rule was. And the rule for trapezoidal rule is on your HSC formula sheet. So step 1 is I would write that rule down. Okay, so I've just gone and copied that formula from the formula sheet, and that's where it stands like that. Now, there are other ways to do it slightly, and I'm just going to do it the way that my class does it. I think maybe Miss College's class might do it slightly different, but the answers will be exactly the same. So what the rule says, it's B minus A over N. Your B is your 5 up the top there. Okay, so you need to know that. Okay, and your A is the bottom number there. Okay, so I've written that just over here onto the right. I've got a 1 and I've got a 5. And what it wants us to do is to use trapezoidal rule with 4 subintervals. Now you need to know what the subintervals are. Okay, so the subintervals, we were making little rectangles up there. We've got 1, 2, 3, 4 subintervals, or 4 rectangles, or 4 trapeziums actually, to work this graph out. In order to have those 4 trapeziums, we've got 1, 2, 3, 4, 5 function values. So you need to know the difference between what are the subintervals and what are the function values. So if you have a look at this formula here, we're going to go 5 minus 1 all over 2 lots of the number of subintervals, and we have 4. So not the number of function values, but our 1, our 2, and we've got 3, 4 trapeziums in there. Now, function A and function B. This is where a lot of people went wrong on this question. What they wanted to do was just chuck in what their numbers were that they popped in here. So that would be 2, 3, and 4. And people popped in 1 plus 5. It's like not 1 plus 5. We need to pop our number 1 into our function. And what's our function? Our function is 10 over x plus 1. So we need to make sure that we're popping those values in there. So we're going to have 10 over 2, the first one. So we're not 10 over 2. Oh yeah, 10 over 2. So if we go function A is 10 over 2, okay, because I popped my lower number there, which is my 1, into the bottom here. 1 plus 1 is 2, 10 over 2. Plus function B, okay, B is 5, so it's going to be 10 over 5 plus 1, which is 6. And now it becomes 2 lots of the other function values. So the 2, the 3, and the 4 are going to go in there now. So once you've got all your values in there, all you're doing is popping it in your calculator. Okay, so I generally do the part in the brackets first and then times by what's out the front. But what I ended up with was 11 and 1/6. And we're looking at area, so it's units. We don't have a unit, so we're going to go units squared. So for 3 marks, you needed to show me that you could get a number out the front here that was correct, that you knew how to substitute in properly, you had the right number of integrals. It was given, it said to 2 decimal places, so I actually was looking for a decimal answer, which is 11.17 units squared. And to get a mark, if you at least showed me that you knew what you were doing and you gave it a good go, you would have got a mark for that. Okay, the next one. Overall, most of these 3 were done fairly well, but there's something I need to show you on this first one, and it's saying differentiate with respect to x. It's something that I think nearly every single person got incorrect on this question. So obviously x happens in 2 places, so it is a product rule. So u is going to be equal to x, v is going to be equal to sine squared x. U dash is going to be equal to 1. V dash, this is where we went wrong. V is sine squared x. What does that mean? That means it's sine x all squared. We need to use the chain rule. We bring the 2 down to the front, and we differentiate and times by the sine x. We take the 1 off the bracket, 2 minus 1 is 1, and we times by the derivative inside. The derivative of sine is cos. So v dash should be 2 sine x cos of x. And what most people wanted to put was 2 cos of x or cos squared of x or some other thing. So you need to be really careful that you know that sine squared x is sine x all squared. And then you're going to use the product rule, which is on your formula sheet. VU dash plus UV dash, or if you think of it as dy dx format. Okay, when I set it out like this, I like to set it out like this because I can actually just do crossing of each other like that. So you need to multiply it. So if you showed me that you were trying to use the product rule, then you got a mark. If you use the product rule correctly, you got your second mark there. So if we sort this out, what would you have gotten? You would have gotten, what do we got? Put my 1 in there. VU dash is sine squared x plus UV dash, which is going to be 2x sine of x cos of x, which you could have then factorized as sine of x and became 1 plus 2x cos of x. But I was happy with that answer there. So I think the main thing there is getting that differentiation of sine squared x right. Okay, this one here. Also not done particularly well. So if that's our y, what have we got? It's also equal to log of 4x squared to the minus 1 to the half. That was step 1. Okay, so in order to get you 2 marks, you need to get it correct. In order to get 1 mark, you needed to use the log law for differentiation correctly. And there's probably an easy way and a hard way to do this one. The easy way would have been to bring your half down the front. so that your y is a half log of 4x squared minus 1. When we differentiate anything that's in the log, it's the derivative on the function. So my half's out the front. Here's my function here, 4x squared minus 1, and we're still going to times it by that half or that 2 that's out the front. And the derivative of 4x squared minus 1 is 8x. This 2 and this 8 here will give me a 4, so I've got 4x on 4x squared minus 1. Okay, if you didn't see to bring that half down, you can still do it. And it's going to be the derivative on the function. Your function is 4x squared minus 1 to the half. And your derivative is going to be differentiating the whole thing. So you're going to have a half times by 4x squared minus 1 to the minus a half. And you're going to multiply by the derivative inside, which is 8x. What that will then have happened to it is the 8x is on the top. The half will become the 2, will bring down to the 2 on the bottom. This top section here with the minus a half will come down, and it will be a half and a half as the indices added together. So you're going to get 4x minus 1. A half and a half gives me 1. And then that 8 and 2 become a 4 again. So we get 4x, lots of 4x squared minus 1. So either way, that's your answer. On the left-hand side one was much easier. Okay, rightio. Next one, part C. You're looking at y equal to 3x plus 1 over x plus 4. You want to find the derivative. You've got a u and you've got a v. This one was done fairly well. You need to show me that you're going to use the quotient rule on this one. And most people were able to get this one out, which was really good. So if u is 3x plus 1, u dash is 3, v is x plus 4, v dash is 1. The main thing was just making sure you showed me that you were going to use the quotient rule. But what is the quotient rule? Copying it down from your HSC formula sheet and then popping your values in there. Okay, most people seem to be able to get to that format. So I've just popped it into the quotient rule. But where anyone that had a mistake, where that went was that's minus each of those terms. And people didn't deal with minusing that 1. So they ended up with the wrong value. If you expanded it, you would have got 3x plus 12 minus 3x minus 1. And all of that was over x plus 4 squared. So what you would have ended up with, the 3x cancelled out. 12 minus 1 is 11. So you should have got 11 over x plus 4 squared. What a lot of people ended up with was that minus did not bring itself over to that plus 1. And you ended up with a plus 1. So you ended up with 13 on the top and you didn't get the correct answer for that. So you need to just show me you're using the quotient rule and then do it correctly to get those full 2 marks. Okay, 22 worth 4 marks. There was a 2-mark question for part A and a 2-mark for part B. Overall, not done very well at all. This is an area that most of you need to go back and have a look at. You need to understand what this actually means, this equation, and where it comes from. And you guys learnt that this came from P equals P0 e to the kt, or in this case minus kt. Noting that this is our rate of change in the population with respect to time, and it's minus kp. There's no kt on this side. You could integrate it, but where it comes from is this equation here. So integrating that would give us this part here. Now, the other thing we need to know is that that's our decreasing rate of the population. In August 2003, there were 3,000 parrots. So that's our original time. At time equals 0, our population was 3,000. And then by August 2013, it had decreased to 2,750. So generally there's a nice simple way that we do these equations. You're normally going to be finding out what the population is at time equals 0. If I popped time equals 0 into here, this part of the equation would go to 1, and I'm going to end up with P0 equaling 3,000. So I've got my population, P being 3,000, e to the minus kt. That's my population equation. It says that in 2013, the population had decreased to 2,750. So when time is 10, So when time is 10 there, sorry guys, my stuff's messing up there. Our population is now 2750. And what that second step of this equation allows us to do is to now find what our K is. So I know that I've got 2750, popping it into this equation here is equal to 3000. E to the minus K times 10. So 2750 over 3000 is equal to E to the minus K10 or minus 10K. That simplifies to 11 over 12 E to the minus 10K. Now this is where, depending on how your teacher does it, you may do it slightly different. I like to take the log of both sides. So I end up with ln of 11 on 12 equals ln or log E to the minus 10K. This is going to come down the front. So I've got ln of 11 over 12 is equal to minus 10K ln of E. ln of E goes to 1. So I get ln of 11 over 12 divided by minus 10 is going to be equal to my K. Popping that into the calculator, I get 0.0087. It wants it to 4 decimal places, and that would give you your 2 marks. So if you found that question was difficult, the way that they ask them generally doesn't change very much. You need to know when you've got a calculation of an increasing rate or decreasing rate of some sort of population, that this rate of change comes from this initial equation, and that when you pop your initial time in, you get your P0, and then you'll find out after looking at the second time what your K is, and they don't change too much from that. If the population continues to decrease in part B at this rate, what will be the expected population in 2023? So we're looking at a population changing from the year 2000 to 2023. So time has changed to 20. What is our new population? Okay, this one's fairly simple. You use your answer that you got before, your K, and you pop that into your equation that you had started to work out before. So you've got that P is equal to 3000 E to the minus 0.0087 T. And that comes from our K and our population. We're just going to pop in to that equation then our time of 10, and that will give us a population of 2,521. So you needed to get that answer to get your 2 marks. If you showed some understanding, you got 1 mark. There were some people that could work out another form of a rate and did it another way, and you would have got some marks as well if you got the same answer. Okay, let's look at the next question. This one was done very, very well. You seem to be able to do your sequence and series. So it was worth 2 marks. The first term of an arithmetic, and that was the main thing there, arithmetic progression is 47. The sum of the first 14 terms is 2023. And we want to find the common difference. So you needed to come up with the formula from your formula sheet that had a sum of an AP that involved A and involved D. And the formula from your formula sheet says that the sum to A equals 2A plus n minus 1D. If I pop my numbers into there, I get 2023 equals 2 lots of 47 plus n minus 1, which is, 13, because our n is 14, 13 times D. And you might have noticed I've made a mistake in there. I forgot my n over 2. Nearly forgot that. So that shows how easy it is to make a mistake on that formula. So my n over 2 is 14 over 2. Sorry, having a shocking one. 2 times 47 plus 13D. Rearranging that, you'll get D is 15. I'm not going to work through that one. That's fairly simple. Okay, so you needed to get your full 2 marks, you needed to get D equals 15. And if you showed me that you knew what you were doing and you used a formula that was the one that was above, you would have got a mark as well, even if you got your answer wrong. I'm just going to move down to question, I think it's 25 on your paper as well. I'm just going to go back and find one because we replaced a question that you hadn't done. So this one's saying on the same set of axes, sketch the graphs of y equals 1 plus cos of x plus y equals sine of x over this domain. To get you 2 marks, you need to get both of those graphs sketched correctly. Now, you should definitely have gotten 1 mark, okay, because we should all know what our curve sine of x looks like. And sine of x, and when we're only looking between 0 and pi, I'm going to pop 2 pi in there because sine of x has a period of 2 pi. Sine of x looks like this. But I didn't want this other section down here, okay? I only wanted the first part. That's what I'm after. Between 0 and pi, you would have got a mark for just doing that. Okay, now y equals 1 plus cos of x. Now, what I suggest you do is you take a pencil into the exam with you and you do your basic graphs either on the main graph or next to it and do a little sketch of what cos of x would look like. Now, cos of x in that same domain is going to start at 1 and it also has a period of 2 pi, but it's out of sync a little bit with our sine curve. So I've just done a little sketch of cos of x over here and look at what's happening there. If it's got a period of 2 pi, then it would repeat at 2 pi. So halfway through that is pi. So where is the graph halfway down? Pi would be down here, okay? And that should be actually -1. My graph's not exactly to scale there. Okay, so what we're doing to that graph is we're moving it up 1 unit. So if this is 0 here, this point here moves up 1 unit. So let's just start looking at this point here. This 1 here moving up will become 2. So we'll be over here at 2. Okay, my point here on my cos, which is at 0, will move up to 1. And that's halfway between. So here, I'm going to move up here. Okay, but it's still going to have that curvy shape like that. And then my part here that's at pi is down at -1 and it's going to move up to 1. So that's the easiest way to get a good graph, is to just draw a little sketch of the normal graph and then shift it around. Generally, the sine curve was done well, the other one was not done well at all. And what you will note from there, that there are 2 spots where your graphs intersect. And that would have helped you find the answer for part B. Part B says, find the values of x for which 1 plus cos of x equals sine of x. Well, they're your graphs from above, and where they equal are at these 2 points. Okay, so if you did your graph really nice and neat, you would have been able to straight off read off that they intersect at pi, but you needed to have the 2 values to get your correct answer. The other spot they intersect is pi on 2, and you could have checked those answers on your calculator without actually having to do any algebra at all to solve this one, and that would have gotten you your single mark.